The first thing you need to understand is that the focal length of a lens is a simple physical property. It doesn't change no matter what camera you put it on, or even if you never put it on a camera at all. This magnifying glass, for example, has a focal length, and that never changes. It's always the distance from the center of the lens to the image plane when the lens is focused at infinity. Now, if our ant friend here decides to take a pencil and draw different sizes of boxes on the image plane, you can see that she's not changing the focal length of the lens at all. The only thing the boxes change is the angle of view that the lens sees out in the scene. The smaller box here gives a smaller angle of view, and the bigger box here gives a bigger angle of view. To dig into this a bit, let's start with the normal focal length, an angle of view of about 40 degrees on the long side of the picture. Now, Uncle Delbert may be asking, wait, who decided that 40 degrees got to be normal? Well, that goes back to the study of geometric optics, and here's a cool little example I got from a 1948 book called Lenses in Photography by Rudolph Kingslake, who was professor of geometric optics at the University of Rochester. To start it out, let's go down to the town square. There's a lot of nice scenery here, including a clock tower, a tree, and our friend Melvin in his purple shirt. Melvin is close to the camera, the tree is in the middle distance, and the clock tower is farther away. And the size relationship among them determine the scene's perspective. Now maybe you like this scene so much that you decide to draw a picture. You take a sheet of glass and hold it out from you. Make sure you keep it at the same distance all the time. Now you take a grease pencil and sketch out the outlines of the things in the scene. Obviously, this grease pencil sketch is going to have the same perspective as seen by your eye because you're actually seeing it as you're drawing it. That's the scene's natural perspective. The cool thing is that you can take your glass sketch home, hang it on the wall, and, this is important, as long as you view it from the same distance you drew it, it will still have the same natural perspective. In general, we can say the perspective looks natural when the angle your eye takes in to view the picture matches the angle it took in to view the original scene. So how does that relate to lenses? Well, now suppose that instead of looking at a glass plate, you're looking at a print of a photo. Back in the 40s, about the biggest print you could order without going to a special lab was an 8 by 10. And if you really like this photo, you'll want to look closely at it, what we call reading distance. If you asked a 1940s optician to make you a pair of reading glasses, he or she would have assumed you're reading at a distance of about 14 inches. And it happens that if you look at a 10-inch wide print from a distance of 14 inches, your eye takes in an angle of about 40 degrees. So, we know a 40-degree lens will give the natural perspective you would have viewed in the original scene, just like our glass plate sketch. If you don't believe me, you can believe the trigonometry.